Good morning. You are welcome in AI with Rao, and let's make AI simple. And in this journey in machine learning playlist, we are here at 16th day. What topic we are going to cover is cross validation, bias and variance. It's a pro tool. What subtopics are there? Why one test is not enough? You can agree with me also. And cross validation, bias and variance, trade-off, exact workflow, pro use. So let's start. If I ask you, can one interview decide someone's future? No. Say, if you take an example in a smart school, even in your class or anywhere, you don't get result of class say 7 or 8 just by one exam. It happens through many midterm exams, okay, then monthly paper, like that, okay. 10 papers happens and average of that is your final score, right? This is exactly what we do in model scoring. Now you understand the whole thing. This is what the story is. Yes, this is what the whole story is. See, if I gave you one exam paper, okay, it can be too simple or it can be too hard for you, okay. So luck becomes a factor, it becomes a chance. Do you think such a big decision we will make based on the luck or chance? No, because training happens and it consumes a lots of resources, so we can't rely on luck. That's biasness we are completely removing. Now you can see right now the diagram. See, these are the data. Now let's talk about in terms of data. So these are the chunks, okay. These are the sets of data over which we have trained our model. The blue one is the training data and this yellow one is the test data. Suppose I train my model on this blue one, and while taking the test that okay, how much my model is accurate, okay, so I took one test. See, this data can be simple, can be hard as well, and based on this data can I tell that no, my model is not trained well, it is scoring only 10% or it is scoring 99%. No, this is wrong. I have spent enormous amount of resources. I can't judge my model's behavior based on one data set, right? So this problem, how we solve that problem is what we call cross validation. You can see again the diagram, okay. You can read the whole thing, that's not an issue. You just see the diagram what it is. So here we took 5 chunk of data, okay, 1 2 3 4 5, and what we are doing, see, the first one is our test data, remaining 4 we did the training of our model. This is round 1 and we measured the score. The score of our model came 88%, written down. Now for round 2 we will take chunk 2 as our test data and remaining we will train. Similarly, you can see now come to the round 5. This 5th chunk is our test data and we are training the model on the first 4 and the model accuracy is 87%. Now if I ask you what is the accuracy, average accuracy of the model, we will just average it and it is 86%. Which one is more reliable, the first one or this one? Of course this one. You can see right now how we trained and test, how we test our model in all varieties of data. So there is no concept of someone is lucky or someone is unlucky, someone is hard, someone is simple. You got the point? This is the strategy and we call it k-fold cross validation, where k is the number, here 5-fold cross validation. You can see I have written down all these things. Now come to the most important thing, okay, this diagram. This green one is the truth of the data, which is the exact 100% correct answer. It's a bull eye. You can see right now, this is a bull eye. If you understand this concept, everything will be super easy for you. Now comes what is bias and what is variance. We will understand this through this diagram. See, the left one has high bias and the right one has high variance. What is biasness? See, high biasness means what? This is the truth. This is the red bull eye, but all the prediction is happening very far from the truth. Still they are consistent. They are together, but they are far from the truth. So you can say they are too simple and we call it underfit. In the right side, you can see this is the Red Bull. They are randomly here and the prediction is randomly here and there. So it has high variance and this we call it overfit. It is too sensitive. If you understand this two diagram, it's very simple, very simple. This is the truth. Now all the prediction is happening very far from the truth. So we call it high biasness, right? Now here someone is very close, someone is very far, and every prediction is scattered here and there. We call it variance. You can see it's varied here and there, right? So this is called bias and this is called variance. But the most important term you need to remember, the bias actually signifies and tells about which one? It tells about the consistency or underfit. Remember these two words. Bias always tells about the underfit property of model and the variance tells about the overfit. So if there is a problem of underfit, what we are going to know? Biasness. And if there is a problem of overfit, what we are going to know? Variance. Simple in mathematical term. And if you can measure, we can correct. Now let's come up with this solution. Now this diagram we have already seen this one. What is happening? I have already described and explained it well. So this is the error and this is the complexity of model. See the blue one, yellow one and red one. Blue one is what? Biasness, means underfit. So the more complex the model becomes, the biasness also decreases. But at the same time, this variance also increases. Variance is what? Overfitting. You can see now what is the comfort zone? What is the sweet spot that we are looking for? And that is the red one. This is called use curve and this is called the sweet spot, the balance one. And as a machine learning engineer, our target is to find this sweet spot by iterating, by doing cross validation of 5, 6, 7 or 8, and then we will come up with, okay, this is the thing. Now we will ask, okay, then how to find this sweet spot? So this is a simple iterative approach. What we will do, we will follow three steps. First, we will try with a few settings, say 2, 6, 8 like this, and then we will validate with this 5-fold average that we discussed in the beginning, that first, second, third, and fourth, and we will write it down how much scoring is coming for model, and then we will pick the best one. Very simple. Okay. Now you can see the code. Here is the code. It's simple English. So what is happening here? We are cross validation score is there, then we are printing this one, then grid search CV that will just do all the training, and then we will find the fitting of the model, which is the sweet spot. Done. Now come to what we learn. Let's recap all these things. So first we understand the example. Why lucky and unlucky is not the thing based on which we decide the property of our model, that what is the score of our model, right? The second thing is the validation. We understand, no, we are going to do with 5-fold validation, and we saw the diagram. Now then comes biasness and variance. Biasness is always the symbol of underfit, and variance is the symbol of overfit. Simple. Now trade-off we understand. How can we find the middle spot and what are the way how we can do the training. This is what we are going to learn. Okay, so thank you so much for being in the video till now.